Hello, everyone, and thank you for joining me today on the Cloud Native Data Management Day event sponsored by VMware. My name's Dean Lewis, and I'm going to be talking to you about understanding your data protection for your VMware Tanzu workloads. Although, to be completely fair, a lot of what we're going to talk about today will actually apply to running any Kubernetes environment on top of your vSphere VMware platform. As I mentioned, my name's Dean Lewis. I'm a cloud solution architect here in the UK, and I also act as a ambassador for the office of the CTO, meaning that I help connect what goes on in the field with our customers and with our communities, engaging through events like ourselves, and feeding this back to our research and development and leaders within the business as well to ensure that we're tracking along your needs and taking it really from there. You can find me blogging at theeducate.co.uk, and you can also interact with me at any point in time on Twitter at SaintDLE. So we're going to look at four main areas today. So what kind of data protection do we need in the cloud native world? And then we're actually just going to dig into those options straight away. So we're going to look at an open source offering from VMware called Valero. We're going to look at an enterprise solution from ourselves, which is Tanzu Mission Control. And we're going to look at a couple of those third-party options that are out there as well for data protection. And then I'll finish off the session today with a quick demo, two, maybe three of those solutions as well in the environment. For those of you following along, you do have the ability to put comments in the live YouTube chat as well. And I will try and take some time to have a quick look at those as well as I move from the slides into the demo. So let's start off with the big question. Why do we even need backup for cloud native environments? Well, in our cloud native environments, we've got a couple of different styles of applications that might be deployed and used by our developers and also our end users within the business as well. So for anything that's stateless, we may need revision control on the YAML configurations that are being deployed for those stateless applications. If the state for that application is stored in a cloud service, then again, we need the revision control on the configuration YAMLs. We may also need backups or durable snapshots for that cloud service as well. One, depending on scale, and two, depending on the availability of the service that you've deployed on top of as well. If you're storing your application state data in a Kubernetes persistent volume, then of course you're going to want to protect that persistent volume. There's a reason why you're storing that data there. You may want to also replicate that into another Kubernetes cluster located in your same data center, or maybe even in a different data center or cloud service. And then finally, what about the state that is stored in the Kubernetes API server itself, so etcd? So again, that controls all of how our Kubernetes resources are deployed and configured. And again, we'd want to back that up and maybe even replicate that into another cluster going forward as well. So think about that configuration management data, config maps, secrets, for example, storage classes. There's a number of those Kubernetes particular resources that sit outside of the application, but essentially link together to make your application possible to run in a cloud native world. So let's dig into it a little bit more because I've thrown some terminology at you there already, stateless and stateful. So if we think about container deployments and orchestration, which essentially is the main value that Kubernetes is bringing to ourselves in our enterprise environment, we have our stateless applications. The storage is located external to Kubernetes cluster. We might spin up and just destroy our application as quickly as possible. We're really adhering to that whole idea that the container is ephemeral and there's no particular configurations that we're interested in or keeping. But again, as I mentioned, revision control is one of them. You may keep your application code up in source control for the core application itself, but there may be other configurations in your Kubernetes cluster that you need to protect. A stateful application, though, is exactly that. There's a lot more pertinent data in there that you need to keep hold of. So maybe host names, IP addresses, especially if you're using things like service type load balancer or ingress, security, so passwords, identities that have been provided to the pods or services. and also writing to storage, which is the main one. So writing the data to our persistent volumes within inside Kubernetes itself. And I've drawn two quick diagrams there as well to show that stateful service. As we can see, very, very basic. There's not too much going on. But in a stateful service, we've probably got more configurations in there as well to make that data stateful. So again, more revision control possibly needed as well. And then if we look at this from a full picture point of view. So here, I've got a full application architecture that's been deployed. It's made up of some ingress. So when I go to theeducate.co.uk/backup demo, the ingress will determine which of my services to send that to. So it may be this set of services backed by pods here, or I might go to theeducate.co.uk/VMware, and that goes to a completely different application in my environment. My service then is going to define how the networking works for my different pods within inside of my namespace as well. And those pods could be fronted and connect to more services and more pods that make up the application as well. And that could be multi-layered. So if you think about this in the sense of here, we've got a set of services, which might be my database for my application. This is my web front end. This could be some sort of cataloging service as well, which basically analyzes some of the data in the database. Some of this data here is going to be stored on a persistent volume, and again, go down to my persistent volume, which is then backed by a data store. Obviously, for myself, I'm from VMware, so we're probably speaking about a vSphere data store here. And then outside of this, we've also got additional items, these configuration maps. This may pass data of how to configure the environment variables within my service running in my pod. We've also got secret data as well. So if we've got a database set up, we probably want to pass through some secure details of how to set up authentication for that database when it's built. So all of these different components make up a full application architecture as a single deployment. However, they do need to be protected from a revision point of view when changes are made, but also from a disaster recovery point of view, if we need to replicate or restore this application into another cluster, into another data center as well. Okay, so now we've gone through the high level scene setting of why we need to protect our data and what's going on there. Let's dig down into some of the offerings. So the first one that I want to talk to you today is Valero, also known as Project Valero occasionally, which is an open source data protection function provided by VMware. It was previously the Heptio Arc product before Heptio was brought into VMware through acquisition. So Valero is an open source tool to allow you to safely backup, recover, and migrate your Kubernetes clusters and persistent volumes. It's designed to work on both your on-premises deployments and in public cloud Kubernetes deployments as well. And it's built with Kubernetes in mind, meaning it was born in the Kubernetes world and designed for that. It's not an existing product that's been reshaped, reformatted, or replatformed for Kubernetes. Essentially, it's made up of three main components. There's a command line interface. There's the server application, which actually is deployed as a set of pods and services inside of the Kubernetes cluster itself. And then there's some plugins in terms of how it interacts with the volumes where your persistent data is stored as well. As an open source project, it backs up your Kubernetes resources to object storage. So anything which is S3 compatible, Google Cloud or Azure storage as well. It can use the ability of a container storage interface driver that has snapshot capability to protect the data. But there are also plugins as well to capture that persistent volume data if snapshots not supported. We obviously support Kubernetes running anywhere. So whether that's your vSphere environment on premise, whether it's AWS, Google Cloud, Azure, or name another service. It is developed today as part of the Tanzu project from VMware, but it is open source. And we do see this integrated into enterprise offerings such as Tanzu Mission Control, which I'll talk about in a slide or two, and other backup software offerings as well, such as Dell EMC Power Protect as well. So essentially, they're taking the open source project and layering on top further enterprise orchestration capabilities on top. In terms of capabilities on the right-hand side, so we can back up all cluster resources that we talked about before, back up individual namespaces, or we can do items and objects based on label selectors. We can back up that persistent volume data either using a plugin called Restic or via the CSI snapshot capability. We can have execution hooks for QSing applications or other operations. So this way, you've got the ability to create your own hooks into your containers to tell the service that it's being protected, so that it may stun I/O operations, for example. Very similar to what we've seen go on with QSing virtual machines for a number of years in a VMware environment. You can, of course, set schedules up for backups. You can control this via the command line tool, which I'll show you a little bit in my environment, or you can even write your own custom resource definitions as well. And then finally, what we expect from all good data protection tools is the ability to restore into a new cluster namespace or into the existing cluster and namespace for data recoverability as well. A high-level overview of its architecture. It's very, very simple. So we start off with the Valero CLI. Using the CLI and kubectl installed on your machine, as long as you've got connectivity and the right authentication in your kubeconfig file, we can interact with your Kubernetes cluster. You can use the Valero CLI to install the Valero control custom resources and the services that are associated as well into its own namespace. Once that's done and up and running, the Valero CLI will interact with the custom resources to kick off a backup of your objects that have been selected. It will run the necessary services to that, and then again, if you're protecting persistent volumes as well, it will spin up the additional Restic services as needed, and then the service will offload that data to S3 compatible object store. So let's talk a little bit about the Restic plugin versus the snapshots port through CSI for that persistent volume data, because that's really key in the environment. One of the reasons that we've introduced the plugin through Restic is because it takes a storage system agnostic approach. So again, as we'll see in a moment with the CSI, where there's some particulars to make that happen, it can be agnostic. There is no snapshot capabilities, so we are taking a copy of the underlying data layer in the persistent volume. So where possible, you must use QS or freeze your file system through an execution hook to ensure application consistency. And that essentially allows you to pause the I/O going on in your persistent volume as we're protecting that data to make sure there's no change going up at the same point in time that we're protecting that data. And Restic works via the file system itself. So it's going to search through the file system persistent volume to understand changes that have gone on between the differing backup differentials. The volume snapshot plugin works slightly different. So it interfaces with the storage system to take snapshots. So we're going to talk with the container storage interface in the Kubernetes cluster itself, which will then call off to your storage system of choice, which then will trigger the backend snapshot for that piece. It will allow you to have crash consistency on a per volume basis, that's per persistent volume. The backup of the data is internal to the plugin storage system, and typically this is block orientated rather than file system orientated like Restic is. So there are some differences there in terms of how that works as well. And like all good systems, we then take that data and we move it off to our object storage once we've got a copy of it. In terms of Valero, because I'm here talking today from VMware, we have a Valero plugin which interacts directly with vSphere, so it understands the construct of vCenter and ESXi host, and also underlying storage that you may have exposed through CSI or other into your Kubernetes environment. There's a volume snapshot plugin for Valero, and that handles the snapshot and the backup and restore of vSphere persistent volumes. So that's understanding how to restore that data and create a Kubernetes persistent volume as a first-class disk on the underlying vSphere storage itself. it requires you to use the vSphere CSI driver inside of your Kubernetes deployment, and you must be using vSphere 6.7 update 3 or higher in your environment. The plugin will back up your persistent volume data to S3 compatible storage, the same as the normal Valero setup. It currently only supports full backups, and it uses a scale-out data mover inside of the deployment in your Kubernetes cluster to move that data externally to the object storage as well. So you do need to make sure that those services running inside of that Kubernetes storage can contact your object store. Sometimes we see customers using Minio, for example, and again, that will run as containers within the system for that object store. Other times we may see a customer use AWS S3 storage, which requires external connectivity to make that happen. In our release of the Valero plugin for vSphere 1.02, we gave you the ability to handle backup and restore for vanilla Kubernetes vSphere. This would bring your own Kubernetes deployments on the vSphere environment. With the 1.1 release, we then supported the vSphere with Kubernetes, also known as vSphere with Tanzu, or its codename Project Specific, which is the native Tanzu Kubernetes offering from VMware at a vSphere level. So that's the integrated offering. And from that point on, we handle the backup and restore for vanilla Kubernetes, guest clusters deployed by the vSphere with Tanzu offering for your developers, and also user workloads that have been provisioned using the supervisor cluster services as well. To have a quick look and a dive into how that plugin architecture at vSphere level works. So Valero will initiate the backup again through the CLI tool, or you can use them custom resources. The vSphere then plugin is called to snapshot the persistent volume. This plugin will call directly to vCenter to find the first class disk located on the vSphere storage and create that snapshot via the vSphere level. Valero then persists the metadata and the snapshot ID that's been created to the S3 object storage, and the data manager will move that snapshot data into S3 using the VMware Data Protection API. And then the local snapshot in the vSphere level will then be removed at the vCenter level. So Valero will call the vSphere plugin, it will call the vCenter, it will snapshot, it will then, a data mover will move this data via the data manager services to the S3. Valero will send the associated Kubernetes metadata itself. Then, when we start to support those vSphere with Tanzu native integrated workloads at the vSphere level, work slightly differently, as we can tell by this more complex diagram in front of us now. So Valero will again be initiating the backup in the guest cluster. The vSphere plugin, once again, is called to snapshot the persistent volume. The plugin writes to the backup driver snapshot custom resource inside of the guest cluster. That guest cluster will write to a backup driver that is used by the supervisor cluster. And the reason for this is when we use the vSphere with Tanzu integrated or native capabilities for deployed Kubernetes clusters, the storage access is slightly different at this level. So storage access for guest clusters is through a proxied supervisor cluster connection. Hence, we take this slightly more complex approach to do it. The supervisor cluster then takes the first class disk snapshot. Valero will persist that metadata and snapshot ID to S3. And again, we have a data manager which goes off to vCenter, pulls up that snapshot and moves it to S3 as well. And then finally, we call off to vCenter to clean up those snapshots as well. Ultimately, the high level, the same methodology is taking place when we use vSphere with Tanzu. Because of this introduction of the supervisor cluster, we talk through that for access to the services, the backup. So if you do have a vSphere with Tanzu environment, there's a slightly different method to think of there in interactivity in the environment itself. Okay, so moving on, we've talked about how Valero is an open source project that underpins all of that. one of the things that we can do is Valero is really good, but it's an open source project. You install your CLI tool, you have to connect to your Kubernetes clusters manually. You install the tool manually, you set up your schedules manually. There's no centralization or consistency between Kubernetes environments. However, VMware has a SaaS offering called Tanzu Control, which includes a data protection feature. Tanzu Control is fleet management for your Kubernetes cluster across cloud-native platforms, and it gives you the ability to have visibility and policy management of your holistic Kubernetes platforms themselves. Provides you the ability to deploy Tanzu Kubernetes grid, so that's VMware's opinionated Kubernetes environments, into AWS, vSphere, VMware Cloud and AWS, and further platforms on the horizon as well. But obviously today we're more interested in the ability to use the data protection workload. And essentially what we're doing here is leveraging Valero under the hood, but we're centralizing that data protection management plane through Tanzu Mission Control. So we have the ability then for each of our managed Kubernetes clusters, whether they're deployed by Tanzu Mission Control themselves, or whether we've brought our own vanilla Kubernetes environments, whether that be OpenShift, bring your own Kubernetes running Ubuntu, for example, into the environment. We then have the ability to enable through the web UI, CLI, or API, the data protection feature. That will then install Valero to that cluster for us. It will also perform the lifecycle management for that across all of these Kubernetes clusters as well. We can also then push out the configuration centrally through Tanzu Mission Control. So which storage are we interested in using and connecting Valero to? And then we can set up our backup and restore options through these single control operations as well. And then finally, if you did still want to use the Valero CLI, which I will show you a little bit of, we can do that as well if you wanted to. But essentially, the main thing here is we've got this enterprise control and scaled offering for data protection, your managed Kubernetes workloads. Now, of course, it would go a little bit of a miss of myself to only talk about VMware. There are also third-party offerings available to protect your Kubernetes on vSphere environments or your Tanzu Kubernetes workloads, whether they're deployed on top of vSphere or into native clouds as well. So let's have a quick look at some of those third-party offerings as well. So the first one is Custom by Veeam. So they have their application K10. It's a high-level overview of it. It provides orchestration APIs. So again, that enterprise level offering to discover your applications inside of your Kubernetes cluster, the underlying components that make up your Kubernetes cluster, and be able to perform the lifecycle operations there. From its infrastructure APIs, it means it's non-proprietary for its storage layer and provides support for both block storage and object storage as well. So you can have that same snapshot functionality that we talked about in Valero, but also with Kasten. And we also then can offload with Kasten to object storage as well. And it has an application agentless framework so that we can use application-based blueprints to trigger execution hooks in your application that are being deployed as well for that application consistency, which is really key. And essentially, from an architecture point of view, Kasten is going to interact with your underlying container orchestration platform, Kubernetes, your virtual or physical infrastructure for that. K10 platform really brings that orchestration there for you, and then additional functionalities to discover those applications, and then also give you the application awareness using execution hooks for you. Another third-party offering would be Portworx by Pure Storage. So they have a product called PX Backup. And again, the features pretty much follow the same route that we've already been talking about. So we have the ability to do application-based backups in your Kubernetes platforms, regardless of where they're deployed. Once again, you have functionality such as native-based awareness, the support for multi-cluster and multi-cloud environments, the same that we have talked about with Tanzu Mission Control and Kasten already. You have the ability to import cloud volumes not managed by Portworx today and bring them under the same management. And then you can layer on top policy management for data, asset management, and backup governance as well. So each of these products essentially come together the same high-level offerings, However, they may work slightly different in terms of their orchestration engine, their UI, and their feature sets, essentially. Obviously, I'm only touching on 2 third-party options for brevity of time today, but there are other third-party solutions that are available as well in the market. You're not limited to everything we're talking about today. Okay, with that, I think we've come to the end of my slide, so I'm going to just quickly stop sharing and move into my lab environment. Just get rid of some of these screens here for you, makes it a little bit nicer. So the first thing that I'd like to introduce you to is Valero. Although I'm not going to show you how to install and configure Valero today for just again saving time, it's an open source project, it's fully documented. If you go to Valero.io, you can find the different versions and feature support that are available today. We have some great documentation of how to get started. We even have an evaluation installation guide as well that tells you how to download and install the tool, set it up on your cluster, and even configure things like Minio for testing as well inside of your environment, so that you can set up a little proof of concept or proof of value of that open source tool for yourself. If I quickly go into my CLI, so this is just one of my clusters that I connected to today. So we've got the Valero tool installed. My machine, we can see here it's going to complain saying that I don't match the server version. So actually I'm running a slightly newer version of Valero than my Kubernetes environment that's supported, but that's fine for today. We can create backups. We can obviously create those backup locations. We can create backups and delete backups or other resources. We can describe the available backups. We can install Valero to our clusters. This is taking that installation package from my Linux machine and pushing it into my Kubernetes environment based on the context that my kubeconfig file is set to today. I can also interact with the various plugins, the REST plugin as well, restore and set up schedules. So all this is very command line based and will be done per cluster that I'm connected to. If I just very quickly do Valero, get backup on this cluster, we can see here I've got 3 backups. 2 of them have failed, mainly because when I was testing this earlier today, I forgot to specify the right parameters for that, so it failed on the backup point of view. But then I've got another backup which I kicked off and was successful. And if I do Valero try backup and give it that backup name, I can see all of the details that have been passed through as well. But again, I'm interacting with this at Kubernetes command line at my desktop, at my laptop type level. So now let's look at some of the kind of enterprise offerings from that point of view. So if I go back to my lab environment, I'm going to go into Tanzu Mission Control here. This is my fleet management. I've got a number of Kubernetes clusters available in my environment. I'm going to go to my second Tanzu Kubernetes grid environment that I've deployed into a vSphere platform. And one of the things that I want to do right now is I want to enable data protection in this environment. So I can click as an administrator, as an operator of the environment. I might even be the application owner that's got access to Tanzu Mission Control through the various RBAC, through workspaces. We're not going to touch on that too much today, but I could maybe even have self-service of enabling data protection myself. That's going to go off and it's going to install Valero on my cluster for me. And that can take a couple of minutes. So if I go back to the correct terminal window for myself right this second, if I do kctx, we're moving to my other one. If I do kget and s, we can see here at the moment, I've got a VMware TMC namespace. This is the namespace where all the services live and are managed. This will start to install various services into TMC for data protection as well. And then as REST runs, for example, REST will run in its own namespace when it's doing the persistent volume point in time backup. If I do kget pods, the namespace of the VMware system TMC, we might even see some of these additional pieces being installed at the moment. So we can just see here we've got an agent updater, the workload, which is creating, and that essentially is my updates being pushed down from Tanzu Mission Control, the centrally managed thing as well. So that can take a couple of minutes just to enable the data protection. So as you can see, it's one click, it's quite easy. So I'm going to go and use my Blue Peter moment here in the UK to go into one of my other clusters where I already have this set up. And what we're going to see once that's up and ready is I've got this data protection is enabled. I can create a backup from the interface. I've also got data protection tab that I can go into as well. My data protection tab, we can see my available backups. We can see here that these were the backups I created with CLI. Obviously, we know these have failed on the environment themselves, so we know that this is going to show up as unknown. If I'd used the right commands, this would also show up as a successful backup, but again, it's centrally managed from that point of view. I can click to create another backup. I've got the ability here to centralize that control of that creating it. So entire cluster, selected namespace, or label selectors, for example. So I'm going to cheat and I'm just going to do selected namespaces. We're going to do my Argo CD. We're going to set my target location. So this is my S3 object storage in AWS I configured, and I can click here to view that. So this is something I've already configured in the system earlier under the administration tab. We click next. I can set my schedule. Does this want to be a one-off? Do I want this to be weekly, hourly, for example? So let's do this as hourly, and we're going to do that at 33 minutes past. How long do I want to keep this for? So this is done in days. And then what name do I want to give this? We're going to call this Cloud Native Data Management Demo. I click Create. And we can now see that that schedule is here, and its current status is pending for two reasons. This will be pushed down to the cluster to configure. So we can now see it's changed to enabled on the screen. And then it will kick in and tell me when it next runs as well, and when the next backup will kick in. I can also then click in to this, and I can see the available backups that are associated with this particular with this particular schedule itself. And then if I want to restore, we can see now I've got a backup that's here. It's given the time and date there as well. So if I went in and I deleted my Argo CD namespace, then I can click here. I can restore this. I can tell it how to restore it. And then I give it a name for this restore, and it will show up in my environment as well. By default, by using Tanzu Mission Control, if there is persistent volume data inside of those particular objects that have been selected, Tanzu Mission Control will handle the creation of the policy, which includes resting for you as well, so you don't have to set up. Whereas if you do this manually using Valero, you've got a couple of extra command lines and considerations for resting as well. So we can now see that we've hit the 33 minutes on the timer up here. So what's actually happened in my environment is this is now running against the schedule. The first backup here was obviously kicking off as the first backup that schedule was first created as well. So we can see it's now running in progress as well. So this is using Valero through Tanzu Mission Control. It's very prescriptive, but it gives you a way to centralize through a fleet management system, pushing out data management as well. So rather than just, again, talk about VMware products, one of the things that I wanted to look at as well today was let's look at one of the third parties. So it wouldn't go amiss to look at Kasten, for example, in an environment, because Kasten are obviously one of the sponsors and contributors behind the Cloud Native Data Management Day. So if I go back to my clusters view, this is my Kasten environment. I'm using the multi-cluster dashboard here. I've got 3 clusters that have been added. So these are my 2 Tanzu Kubernetes grid clusters, and I've also got an OpenShift cluster here as well. These are all running in my same vSphere environment, and they're all using the vSphere CSI driver to interrupt the vSphere storage of that persistent volume data as well. So because I'm using the K10 multi-cluster, I can use the dashboard to set up global resources. So let's click into that. So straight away here at an enterprise level, I've got the ability across all of my clusters to configure a location profile. So where do I want to store my data? So we can see here, this is an AWS S3 storage location. I can then set up an infrastructure profile. So I've set this up for my vCenter environment. So this is running VMware on AWS. I can then set up a policy. So we can see it's very simple. I've set up a policy. It's going to look for all resources in the namespace of Pacman. It's going to snapshot this hourly, and it's going to export that to my global configuration of my location profile for my S3 bucket. And we want to export that volume data as well for durable backups. And then finally, I set up a distribution. And this distribution ties together which clusters I want to target in my multi-cluster configuration, which resources I want to pull together. So I want to obviously bring my policy together, my profile. So that's how does custom know how to do the snapshots of those first class disks, and then where to export that data to my AWS. You can see here the last data was synchronized 3 hours ago, so that's the last time I made a change to this distribution itself. Now, if I go back to my clusters, I click into my TKG workload 02, we can see I've got one compliant application, I've got one backup policy that's been pushed out. And we can see here, my policy has been running on the hour, and the policy is the pattern and backup. And I added the word global here to signify it was a global policy that's been pushed out. Within my Kasten environment, I can then go into here. I can see all of my applications that are available. I can see that there's a lot here that are architected by policy. So I could create a policy on the fly if I really wanted to snapshot. So let's set all this to zeros and we'll just put 1 hour in there. We're going to again enable this to be sent off. We're going to select my location profile. It's already selected other situations for this application that's been discovered for me, but I could change if I wanted. You can see it's already selected this application by name. I can also include cluster scoped resource if I really wanted. So this would include any custom resource definitions, cluster roles, or cluster bindings. And I can set filters in there about how they're selected as well as part of this backup policy. I can then also set those advanced settings. So this is where we do those execution hooks or action hooks for our application, so we can QS or make the backup consistent as well into the environment. So calling off to my database and pausing the IO or those transaction log writes, for example. And then I can tell it how to do that and which blueprint to run with that. I've got those details in there as well. I create that policy. Oh, I do have a problem. So there we go. I unselected that by mistake. So we'll create the policy. One of the things that I can do through Kasten as well is I can view all of the YAML that creates all this as well. So I can see that custom resource definition that's set up when we install Kasten into our cluster that's used to create this policy for the backup. So I could also automate this as well through the command line, through custom resource definitions if I so wanted, rather than the UI. And that could be used by application developers as well. I'll click to run this policy once. I go back to my dashboard, and then we can see that it's running here. If I so wanted, I can go into my compliant applications again. So we'll look at my Pacman. I can look at the ability of what's available there to restore. And very similar to Tanzu Control, just a different looking UI for this. I can select here. I can select to restore from snapshot, which is this today action here. So this is restoring the snapshot at the vSphere level for that first class disk. Or I can select to restore from that exported data, which is in my S3 object store instead. And it's very simple. I can select to restore. Probably one of the differences here with Tanzu Control versus Kasten to call out is I do have some additional options how I restore this. So I could, again, run action hooks in my application before and after it's restored. I can restore to different namespaces. I do have the option to restore to different clusters as well. I can do data only restore. I could apply transformations as well. So maybe if I'm restoring to a different cluster, for example, I might want to change that storage class to a different name because that storage class is different in a different cluster. Maybe my cluster's running Azure, for example, rather than my vSphere environment when I do this restore. I'll just untick that. I can then select which artifacts are going to be restored. So obviously the snapshot that's been exported for the persistent volume, which is my Mongo storage. Do I want to restore any of the other artifacts as well? And again, I've got a couple of different options in how I select those as well. Okay, so that was a really whistle-stop tour today around thinking about some of the considerations and some of the tools that are available today to protect not only your Tanzu Kubernetes workloads, but any Kubernetes workload running in a vSphere environment as well. I hope this was useful for everyone listening. Just going to go quickly back to the slides as well. It would be amiss of myself not to kind of round up on a quick resources slide. So if you're really interested in data protection, there is a data protection working group as part of the Kubernetes community. I'll put the link up here. That GitHub repo has all the details how to get involved today. Of course, is the open source project, Valero.io. For more details, if you want to use this in a vSphere environment itself, that plugin. If you want to learn more about Tanzu Mission Control, go to our tanzu.vmware.com website, Kasten.io to learn more about Kasten, portworx.com to learn more about Portworx, or of course, our good old search engine friends, Google, Bing, or others, if you want to look at other third-party options as well for backing up and restoring your persistent data inside of your environments. So thank you very much, everyone that's joined us today. Really appreciate it and enjoy.